Medical students and residents currently practice resetting dislocated joints on live patients. Considering these are difficult procedures, this approach isn't practical. We, the Skeletal Squad, have created an adjustable orthopedic model to simulate a shoulder and hip reduction that students can practice on so they are properly trained before their first live procedure. Our model involves a movable joint consisting of a socket with two holes, one for the correct position of the bone and one for the incorrect position. The socket is 3D printed with 100% infill, so it can hold the weight of the rest of the model. The second part of the joint mechanism is the ball joint that can be pulled out of one hole, moved along the opening of the socket, and then placed back into the other hole. This ball joint is zip tied to a PVC pipe representing a bent arm for the shoulder dislocation procedure. The spring connecting the ball joint to the socket can handle the 60 pounds of force needed to reset the shoulder joint. These springs can be replaced using a screwdriver to handle more or less load depending on the procedure. In addition to the springs, we also feature upgradability by allowing the user to switch between the position for a shoulder and a hip dislocation by loosening the wing nut at the top of the model, rotating the joint along the slot where it connects to the frame, and then tightening at the new position. During the procedure, the user aims the laser, which is zip tied to the PVC pipe, at the photoresistor targets in the cloth of the frame. An Arduino behind the frame counts the amount of targets hit, and once the limit switch is clicked, feedback will be displayed on a screen and the program is reset. The wooden frame of the model is supported by gussets and is clamped to the table so it doesn't move when the user pulls on the device. For the shoulder reduction, the user pulls downward on the arm and turns it 90 degrees to slide into the other hole, then pulls the arm upward to hit the correct targets in a line and receive feedback. For the hip reduction, the user pulls on the leg to bring it up 90 degrees, tilts the leg away from the joint, and uses the leverage of their arm to slide the joint into place.